Welcome students. In our last lecture, we had discussed up to rule 3. Now we will discuss rule 4. What is it? Okay. Considering a differential equation of the form m dx plus n dy equal to 0, which is not exact. Right? Now if we have 1 upon n of del m del y minus del n del x is a function of x alone, say fx, then e power integration fx dx is an integrating factor of m dx plus n dy equal to 0. So earlier we from our 3 rule what we learned is that from first rule, by the method of inspection we are finding this differential, okay, and by second rule 1 by mx plus ny was our integrating factor, and in rule 3 1 by mx minus ny was our integrating factor. Now here you just you need to find out, see, m is with dx na, so now you have to find out del m del y, okay, then n with respect to x, okay, here m with respect to y and n with respect to x, then you subtract del m del y minus del n del x, okay. Now the second term is what, del n, so divide by n, and here is x, so that will be function of x alone. So by this way you just remember the formula, okay. So del n del x, so n is second term, so we divided by n, and below this is x, so we need to find out function of x, okay. If this value comes as a function of x alone, okay, there is no y, that is fx, then what will be integrating factor? E power integration of fx dx, right, of m dx plus n dy. Then after multiplying by this integrating factor, the equation will be exact differential equation, and by the same method we can get our final value, right. So considering this example, here m is x square plus y square plus x, okay, and n is xy. Next del m del y, then del n del x. See, these two are not equal. Now we calculating del m del y minus del n del x, that is y divided by n is xy. What ultimately you get? 1 by x, that is function of x alone, okay. So what is our integrating factor of 1? E power integration fx dx, so that means 1 by x dx, that means e power log x, that is x. So integrating factor of 1 is x. Now multiplying 1 by integrating factor, what we get? X cube plus xy square plus x square whole into dx plus x square y dy equal to 0. Now this is an exact differential equation. Now integrating, how we solve it? Integrating m dx, treating y constant, plus those term which do not contain x, but here second term contain x, so we are not integrating here, okay, equal to constant. So what is our final answer? This is our final answer, right? Similarly, you see the second example. Here this is our m, this is our n, so this is like m dx plus n dy equal to 0. Next calculate del m del y, then calculate del n del x, then del m del y minus del n del x divided by n, you get 3 by x, that is function of x alone. So what is our integrating factor? E power integration 3 by x dx, that is 3 log x, that is e power log x cube, that is x cube, right. Now multiplying 1 by x cube, this equation is now exact. So how we solve it? Integrating m dx, treating y constant, plus integrating n dx, those function of x, those function of n which do not contain x, but both the term contain x, so we are not integrating the second term, right. That is our arbitrary equal to arbitrary constant. So this is our solution, right. Now you do same in the same manner this exercise, okay, 2h. Next, rule 5. So rule 5 is that earlier we did what? 1 by n. See, what we did, 1 by n del m del y minus del n del x. Now this is totally opposite. Now n with respect to x, del n del x minus del m del y, del n del x minus del m del y, and since m is second term, so divided by m, here is y, so we need to find out if this will be a function of y alone. Okay, say f of y, then e power integration f of y dy will be our integrating factor of m dx plus n dy equal to 0. So solve this problem. M dx plus n dy equal to 0, m is this, n is this. Now calculate del m del y, then del n del x, right? Now you find out del n del x minus del m del y, right? This is this, so this is like minus 4m by y. Now divided by m, you get minus 4 by y, which is a function of y alone, right? So what is our integrating factor? So integrating factor is e power integration f of y dy, right? That is e power minus 4 log y, that is 1 by y power 4. Now we need to multiply 1 by y power 4. Okay, that is we get this. Now this is what? An exact differential equation. So integration of m dx treating y constant plus integration of n. So integration of those function of n which do not contain x, but first time contain x, second term x, third term contain x, so we need not integrate the second function. Okay, so our final answer is this, right? Okay, so now we solve this example 2. M is this, n is this. You calculate first del m del y, then del n del x. Okay, now you calculate del n del x minus del m del y. Okay, divided by m, you get 6. So 6 is constant, so you can consider it as a function of y alone. Okay, so integrating factor of 1 will be e to the power integration f of y dy, that means 6y e power 6y. Now multiplying by e power 6y, the equation will be exact. Now in the same fashion you calculate the solution. Okay, now do this exercise 2i. Okay, so we are not learn this rule 6, just keep it. Okay, now come to another linear differential equation. Okay, now see, earlier our differential equation was of the form m dx plus n dy equal to 0. Okay, now here the linear differential, the most general way to write a first order differential equation. Okay, by dy dx plus py, okay, equal to q. So, sorry, if it is dx dy plus py equal to q. Okay, let me check. Okay, dy dx, right? Dy dx plus py equal to q, because p is our dependent variable. First one is first order derivative dy dx y with respect to x plus py. Okay, so this is the most general way to write first order differential equation. Dy dx plus py equal to q, where p and q are any constant or function of x alone, Okay, if there is y square, then the differential equation is not like first order differential equation. Okay, because this will be non-linear. Okay, first order linear differential equation, first order, this will not be a first order linear differential equation, because in linear the power should be 1. Okay, so that is why p should be function of x alone, because p does not contain any y. If p contain any y, then the power raised to more than 1. Okay, that is not possible. Also q is constant or function of x alone, right? Now what is the process to solve such type of linear first order differential equation? Similarly, like in the same fashion, we need to calculate the integrating factor. Okay, what is the integrating factor here? You just remember integrating factor equal e power integration p dx, e power integration p dx, right? Next, if we multiply the differential equation 1 by integrating factor, the left hand side will be, we can write ddx of the final answer we can write y into integrating factor equal to integration q into integrating factor dx plus c. Okay, understood or not? See, what is our linear differential equation? dy dx plus py equal to q. Now what is our integrating factor? Because the e power integration p into dx, because dx is below, so integration e power integration p dx is our integrating factor, right? When you multiply this by integrating factor, this term can be written as, left hand side can be written as d of y into integrating factor equal to q into integrating factor, right? Now if you integrate both sides, what you get? Y into integrating factor equal to integration over q into integrating factor plus c. That is fine. Now you solve one problem. Okay, suppose this is given to you. You first convert it into dy dx plus p of x into y equal to qx. So what is px? 10x plus 1 by x. Now what will be integrating factor of 1? E power integration px dx. So integration of 10x is what? Log of sec x plus log x. So that is multiply x log x, sorry, x sec x. So our integrating factor of 1 is x sec x. Now the required solution is what? Y into integrating factor means y into x sec x equal to integration q into integrating factor, that means sec square x dx plus c. So integration of sec square is 10x, so yx sec x equal to 10x plus c. That is your answer. Similarly, do this b, example 2 of b. Here you need the same problem. So first you convert the problem into dy dx plus px y equal to q. Px is this, q is this. Next you calculate the integrating factor, that is e power integration of p dx. So you may first do this integration separately, integration p dx, then you just put it over here. So you get 1 by 1 minus x square. Now this term, when you multiplied 1 by integrating factor, this term can be written as ddx of y into if, right? So this means y by 1 minus x square equal to integration of q, that means right hand side, into if, means 1 by 1 minus x square dx. So this is like 1 minus x square whole to the power 3 by 2, and this is x. So if you put 1 minus x square equal to t, this is minus twice x dx equal to dt. So after integrating you get up to this. Here is c. Now for second problem, there is a one particular condition, that is when x equal to 0, then y equal to 1. So what you have? Y1 equal to 1 plus c. So c equal to 0. So what we get? Y by 1 minus x square equal to 1 by 1 minus x square whole to the power 1 by 2. So y is root under 1 minus x square. That is your particular solution, right? So another thing is that if our differential equation, linear differential equation of the form, earlier it was dy dx plus py equal to q. Now if it is a dx dy plus p1x in x, okay, equal to q, then integrating factor will be e to power integration p1 dy, because d with respect to dy we are differentiating. So in e power integration p1 dy. So required solution will be x into if equal to integration q1 into if into dy plus c, right? Okay, let me see if there is any application here. You get some application. Okay, here see, if we add like dy dx equal to what? Y by x plus 2y cube. So you cannot separate na y only now. So that is why if you calculate dx dy, that will be what? X plus 2y cube by y, right? So this is like 1 by y into x plus 2y square. So you can separately you can separate it like dx dy minus 1 by yx equal to 2y square. So if will be this, and just do like this.